If you did not get full points on your binder check or the constructed response practice test, you can still turn it in. If you want to resubmit your binder check, I will check that in person because I know that's a lot to have to submit online. But you need to show me all your papers again. I do not remember what each individual person was missing. All seven again, I would need to count. And then the practice test, you just upload to Schoology, take pictures of it, and I'll update it there. I don't want to check. But you have 3 study guides, all of which resemble the actual tests. In the slideshow, I also have videos from last year because the test didn't change that much from last year. So you can watch the videos from last year, maybe find your question that way. I'm recording all my classes today, or again, you could always email me or ask later. But if you don't ask, then I guess you just never know. And the one that was requested right now is on the online one. Number 3, if you want to follow along. So if you don't need help with that one, just continue working quietly by yourself. But let's go through that one first. And this was the one that I was absent that you guys had to watch the video and learn from, but it's really easy actually. We have some residual plots shown here, and residuals are your, sorry, trying to get my pen to work. Residuals are the actual data minus the predicted data. Actual comes from like an actual experiment, an actual survey that someone conducted, whereas the predicted comes from the trend line itself. Sorry, trying to get it to right, but it won't. I'm going to restart my computer. But you can also make the residual plots with technology, and it always does it around the x-axis. So think of it like for the data point 1, you have an actual output and a predicted output. Ideally, you'd want that to be closer to 0 because then that means your linear model was a good predictor. So the closer it is to the x-axis with points clustered around it, the better it is. So here's my options. Yours could be shuffled, so I'm just going to scroll real quick. So A, B, C, and D. Which one looks like it would be for the best fit? Yes. A. It's almost like your trend lines too. Like you want your trend lines to be through the middle of your data where the points are clustered around it. For your residual plots, which will always populate around the x-axis, you want it to be close to it with the points clustered around it. Like B is just too far. C has all the points above, and D has all of it below. You want it in the middle where the points seem to be clustered around it. So good on that one? Okay. And that was really all you needed for residuals. I mean, there have been years where we made you calculate them and stuff, but you don't need to for this test. So just know that that was the one question for that one that I was asking. Other questions from either parts of the study guide? Yes. Number 4 on the online. Hopefully that's me, right? We'll see. Jen periodically kept track of the costs of the product to the sales in millions over an 8-month period. Which equation is the best model for sales S as a function of cost in dollars? So this one is like when we did it by hand, except for you have options now. So what you need to envision, because this is online, granted for your online test tomorrow, I always give you a packet and you can do your scratch work on there. But for it being online, since you can't write on your screen, you'll just have to envision where a line would go that is going through the middle of your data where the points seem to be clustered around it. So I can draw on my screen. So I will snip it and put it somewhere because for some reason it doesn't want me to do it directly on here. right, but this is number 4 from the online. And again, tomorrow you'll have it printed for you too. You're going to make a line that goes through the middle of your data where your points seem to be clustered around it. So in my opinion, I think this would be my middle of my data. And from there, once you draw your line, you're going to find 2 parts that you can see really clearly without having to estimate. So here's what I mean by that. Right here. It's like right in the middle of the grid line. The line goes through it perfectly. I'm going to pick that coordinate as one of the ones I'm going to use to estimate my slope. Does it have to be a data point? Like you don't remember, or it doesn't have to be that? Okay, so let me say it again. Everyone pay attention now, because now I'm calling some people that might be onto something else. Lines of best fit, because that's what we're being asked to estimate right now. You have to make them go through the middle of your data where your points seem to be clustered around it. Does it have to touch all the data points? Does it really have to touch any of the data points? So when we are estimating the line, like the y equals mx plus b of the line, it might not even be that any of the data points are nicely put on the line. You are just looking for areas of the line that you don't have to estimate. So like here, I don't really have to estimate that one because it's nicely on the tick mark. And then I just need one more in order to estimate it. Anyone want to pick the other point you picked? That looks easy to see on my screen. Okay. So 3 being here, 3.5 being maybe a little more up there. It's like a little above the line. If you picked that one, I don't think it would drastically change your
the one like on the y-axis. Like it said.
Oh, okay. Oh, okay. This one you mean.
Mm-hmm.
So then reading it would be 3 for the x, or you mean 3.5?
Yeah.
Okay, let me go. Okay, 3.5 is here, 7 is here. Good, I like that one. It is nicely on the grid line. The x is 3.5. That's why I kind of read it wrong when we were talking earlier. Because x comes first, y comes second. And are we always going to draw our lines the exact same way? Are we always going to pick the exact same points? So that's why it's called an estimate. It should be close, but it probably is not going to be exact. Remember that in y equals mx plus b, usually the m and b are numbers. That's what's shown here. The reason I picked the 2 points is because to estimate the slope, I'm going to use my average rate of change formula. This helps me find the m using 2 coordinates. I think that's a little easier than that. So when you pick your 2 points that you can see really clearly, make one of them x1, y1, the other one x2, y2, plug it in and simplify. So the way that I labeled it, I'd be doing 7 minus 8 over 3.5 minus 2.5, x2 minus x2. Any questions on that side? Am I providing you this formula on your test? No, so please have it memorized. I mean, it's basically rise over run. It's the change in y divided by change in x, but when you do plug in your numbers, you should see that the points from the same coordinate pair end up being on top of each other in the formula. Okay, like that should happen. But anyway, what's 7 minus 8? -1. What's 3.5 minus 2.5? -1 divided by 1 is -1 for my slope. So looking at my answer options, here's all my different slopes. See if there's any you can exclude that are just a little too far off from the -1. Are there any? Okay, for this purpose, I would eliminate this option because, I mean, the other ones are just closer to -1. They just are. This one might be iffy, but like, look at your line as well. Can you predict where the y-intercept is gonna go? Like, is it visible this time? So my y-intercept is about what number? 9 actually, because it goes 2, 3 there, 4, 5, 6, 7, 8, 9. So if my y-intercept is about 9, this is what I'm estimating it to be in slope-intercept form. Are there any of these options that I can exclude based on the y-intercept? Okay, because C has a y-intercept of what? 0, and it really doesn't look like this line is going through the 0, right? So don't pick that one. Now between these two, knowing combine my slope and y-intercept, which one is closer? A on my screen. It might be shuffled on yours, so I don't know. Don't just blindly copy. But like, you see how this might be my answer key, but if you wrote this on your test, like for your constructed response, for example, you'd still get the points. Because again, like, we're not gonna pick the same exact points, we're not gonna draw our lines the same exact way, but it should be something close. All right, questions on that? Questions on others? Yes. Number 6. Okay. So Mary's driving home from California. The following graph records her distance from her house and her time spent driving. I have to snip this, so give me 1 second. And then we're going to be selecting all that are true, and there's kind of a long list. So you have to be able to relate it back to the real world situation. I hate how it doesn't just do it straight. Okay. And yours might be in this order, they might not be. So again, don't just blindly copy. Hopefully you understand everything that's going on when we're done talking about it. Okay. So it's not labeled. Maybe that might be helpful to put what the x-axis should be and what the y-axis should be. It also didn't tell you like x is this, y is this. So we're comparing distance from home and time spent driving. What do you think should go on the x-axis? Distance or time? Okay, so you think like her distance will be numbers 2, 4, 6? Okay. I mean, we don't know how far our home is from California, but typically when we're labeling axes, what's independent goes on the x-axis and what's dependent goes on the y. So between distance and time, what is something that you can't really change? All right, guys. Trying to get you to understand something. What needs to go on the x-axis? I'm trying to walk through there, but you're not even paying. The independent variable, the one that you usually can't change, goes on the x-axis. Between distance and time, what can you not change? Time. Right? Like, just because I drive 3 miles, I'm not changing time that way, am I? No. So time needs to go on my x-axis. If one of the variables is time, it's almost always on the x. So this is going to be my time, probably in hours, but we can see that it's time. And then my y-axis would be distance from home. right? She's driving home from California. So this is kind of telling me that she's at her farthest distance from home at the start of her trip, right? And then as soon as she gets home, there's 0 miles between her home and home. Okay? So that makes more sense. That should hopefully better help you understand these. So is the y-intercept 300? Yes. Here's my y-axis, y to the sky. Here's 300. Yes, that's my y-intercept. The y-intercept is how far she is from home when she starts driving. You guys agree with that? Distance from home, minus 0. She'll be driven for 0. Anything? Okay, good. The slope of the line is negative 65. So for that, you'd actually have to calculate it. This one's actually not too bad to do rides over run, but you could also do that other formula I showed you. I'm going to do rides over run. I'm going to pick 2 parts that I could see really clearly. My rise going from 300 to 200 is what? And we're going down, so it's negative 100. And my run going from 0 to 2, so pay attention to your labels, 0 to 2, with my runs. Rise over run, my slope is, so not negative 65. Is the y-intercept 6? No, that's my x-intercept. Slope of the line is negative 50. Yep, we just calculated that one. The slope represents how many miles she still has to travel. So for that, kind of use those little tips I gave you before, and maybe let me put the negative 50 instead. So her slope is negative 50. And again, it's usually rise over run. So like my y-axis was distance from home. Probably in miles, I would say. And then my x-axis was time, probably in hours. Again, it didn't say. So what her slope is saying is that every 1 hour, she's traveling 50 miles. Or she has 50 miles less to go. But slope is average rate of change. So on average, it is decreasing by 50 for every 1 hour. Is that the same thing as saying how many miles she still has to travel? No. It can help you find out how many she still has to travel. That would be like the y of it for each coordinate. But it's just telling you what her miles is changing by each hour. Okay. Then it says the y-intercept would be the constant term in the equation of the form y equals mx plus b. What does the word constant mean? Or what? Okay, that is true. But like when I say constant, coefficient, variable, constants are our okay. So normally in slope-intercept form, only the m and b are replaced with numbers. So our slope we already figured out, our y-intercept we already figured out. Which of these would be considered my constants? No, x is a variable. Or what? The 300 is a constant because it's a single number. Constants are single numbers. Say it with me. Constants are, okay. So there's a difference between constant and like coefficient. Okay, negative 50 is a coefficient, 300 is a constant. So yes, the y-intercept, which is 300, would be the constant term in y equals mx plus b. Lastly, the slope represents her average speed. Now, being distance over time, like miles over hours, you might think so. But remember, our slope was negative. So her speed is actually 50 miles per hour. Our slope is negative 50. So we're not going to pick H, even though it sounds like it'd be a good answer. Remember, our slope is negative. So what our slope is saying is how many less miles she has to go for every 1 increment of time. So only the ones I circled, again, don't blindly follow. It's the ones that say the correct things. Yes, that's in the okay. Other questions? 7 on this one. And keep in mind, I do post a constructed response later, so that doesn't mean like, oh, I never need to do it because Ms. Medina will just post it later. I hope that you're just engaging with it, seeing what the answers should look like, hopefully doing better on your tests than on your practice tests. Because when I grade your practice test, I just see if it's complete, not if it's right. So you need to check that it's right when you go home, and I post it later. Okay, so among those that like snowboards, what's the probability that the respondent also does not like skateboards? So the trick with these is you just have to read them very carefully. Notice that our answers are percents. To get a percent, what math do you usually have to do? Division. The hard part is knowing what to divide, but it always tells you. You just have to read it and look for phrases that tell you what the denominators would be. So like, out of those who blah, 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 given that they blah, blah, blah. In this one, it's among those that, that's one of those phrases that tells you the next, I don't know, category should be my denominator. It's not always going to be what's written first. It might be written second. So look for those phrases, out of those, given that, among those that, and that'll be your denominator. So we're saying among those that like snowboards, how many like snowboards? 27 like snowboard. How many total like snowboard? So out of those people, what is the probability that the respondent also does not like skateboards? So out of these people, how many do not like skateboards? So that is what we are dividing. When you divide it, you should get 0.4 repeating. And to make it a percent, I just times it by 100%. And then that's my answer. All right, don't overthink it. Just, that's like me saying, out of all the girls in this class, how many have blonde hair, right? I'm not saying how many people in my whole class are girls with blonde hair. I'm just saying out of the girls, that would be a different percentage than if I did the whole class. Okay. Questions on that one? Okay, questions on other. Any from the constructed response? We can talk. I think out of all the tests on this constructed response, I expect more complete sentences because there's not that many calculations that you did this minute. So some of them are really just like, is it positive or negative? Please don't leave those ones blank. Guess if you have to, it's a 50-50 chance. Make up a reason even if you have no clue. But no other questions on anything? Number 2 on the online one. So that one is, I can understand why that one's tricky because they're giving you a relative frequency table instead of telling you the totals like it did in the one we just looked at. Know that, because sometimes they do give you the frequencies based on like a column total or a row total. This one's just out of a grand total. And I know that because here where like the totals intersect, it's 1. And it can't be bigger than 1 if that's the case. If it was percents, then it would be 100%. So the proportions are still going to be the same as if it was like normal numbers, not decimals. And what you're doing in each of these is selecting which are true. So you have to do every single one and see what you get. and if it matches what they say. And again, the hard part is just knowing what to divide. So we have the probability that a student likes football, given that, so that's like a signal phrase that tells me I need to divide by whatever it says next. Given that a student is between 8 to 10 years of age. Okay. So the phrase given that, pretend it's not lopsided. Whatever follows the phrase given that is going to be your denominator. So how many students are between 8 to 10 years of age? 0.35. Out of those kids, so we're looking at this row because it said out of the kids that are 8 to 10, how many of them like football? So we're going to divide that. Again, the proportions are the same. Like they didn't give you numbers this time, but it's still, you're dividing this by that. When I divide it, I get this decimal, which is that 0.12. So then I'm not going to pick that one. All right, so don't pick the one that says that. Let's see if I have time for a couple of these others. I think I might just only have time for one more of these, and then you could test out the others yourself now that I helped you. Okay, so the probability that a student is 14 to 16 years old, given that, so whatever follows this phrase is going to be my denominator, that the student likes basketball. How many total students like basketball? 0.35. How many of those kids are 14 to 16? 0.08. Divide that. 0.08 divided by 0.35. I get 0.23 as my decimal. So don't pick this one either. These are both incorrect. So it's between the other two options, which I don't have time to show you today. If you're still struggling, you could email me and I could explain it to you. But that's how you're figuring it out. Just knowing what to divide.